Hi and welcome to this video on standard index form, GCSE level, maths made easy. So in this video we're going to try and understand more about the standard index form, also known as scientific notation, which we use in maths and physics and science to write very large numbers or very small numbers so that we can understand them more easily. We rewrite these large numbers and small numbers in terms of powers of 10. So let's just go over what we mean by powers of 10. So 10 to the power of 2 means 10 times 10, which is 100. 10 to the power of 3 means 10 times 10 times 10, which is 1000. So if we wanted to write 8000 in terms of powers of 10, it would be 8 multiplied by 1000, and our 1000 was 10 to the power of 3, so this becomes 8 times 10 to the power of 3. When we're writing in standard index form, this is the general rule, a times 10 to the power n, where a is a number between 1 and 10. So it's not 10, it can't be two numbers. It has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, point something, 1 point something, 2 point something, yeah? So if we've got 430 and we want to write that in standard index form, the decimal point has to be between the 4 and the 3 here, so it's 4.3. And then how many places do we move the decimal point to get back to our non-standard index form number? So we have to move the point here, 1, 2. So 2 places, so it becomes 4.3 multiplied by 10 to the power of 2, or 4.3 times 100. Okay, let's just go over that with this number, 4520. If we want to write that in scientific notation, the decimal point has to be between the 4 and the 5 for 4.52. So which power, or what power, do we need the 10 to be? So how many places do we need to move the decimal point to get back to our non-index number, non-index form number? So it's 1, 2, 3 places, so it's 10 to the power of 3. So 4.52 times 10 to the power of 3 is our standard index form of 4520. Let's try a very small number, so 0.022. So again, our decimal point, according to this rule, has to be between the 2 and the 2 here, so 2.2. Okay, so how many places do we move the decimal point to get back to our non-standard index form? So we have to move it 1, 2 places. So in this case, it's minus 2, 2.2 times 10 to the minus 2. Okay. Right, if we're calculating in standard index form and we get a number which isn't in our scientific notation, but it's still to the power of something, we have to move the decimal point. So here we'd have to move the decimal point 1 place to the left to get 2.25, and then we'd have to adjust our exponent on the 10. So if we move left, if we move the decimal point left 1 place, we increase the exponent by 1. If we move the decimal point right 1 place, we decrease the exponent by 1. And similarly, if it was left 2 places, increase the exponent by 2. Right 2 places, decrease the exponent by 2. Okay, so let's have a go at that. So if we got 22.5 times 10 to the power of 3, not very clever because it's not in scientific notation, so we want the decimal point to be here between the 2 and the 2, 2.25. So we're moving left, moving the decimal point left 1 place, so we have to then increase our exponent by 1. So this becomes 2.25, and this 10 to the power 4, increase the 3 by 1. Okay, 0.76 times 10 to the minus 1. This isn't in standard index form. The decimal point should be here, so that's in standard index form. So move the decimal point right one place to give us 7.6, and then this, our exponent, we have to decrease by 1, so that becomes minus 2. 7.6 times 10 to the minus 2. 0.3 times 10 to the 4, so we need this point, this decimal over here. Okay, so moving right one place, this 10 to the 4 we have to decrease by 1, so that becomes 3 times 10 to the power 3. When we're doing addition of numbers, if the exponents are the same, so we've got 10 to the power 2, 10 to the power 2 here, we can add them. So we can just add the numbers, 6 and 7 is 13, and then keep that 10 to the power 2. So that's 13 times 10 to the power 2. Okay, 6 times 7, 13 times 10 to the power 2. Then using this rule, we convert this into standard index form. This 13 becomes 1.3 times, and then because we're moving left one place, we're going to increase this exponent by 1, so increase the 2 by 1 to give us 3. So 1.3 times 10 to the power 3, which is 1,300 in non-standard index form. Okay, let's just go over how we do addition and subtraction when we have the numbers in standard index form. Now addition, there are two ways we can do this. One, we can change the number from the standard form to non-standard form, and then add and then convert it back to standard form. So I've done that in this example. So 6 multiplied by 10 to the minus 1 is 0.6. Remember, minus 1, we're moving the decimal point left one place. Minus 1 times 10 to the minus 3. Remember, minus 3, we're moving the decimal point, which is here next to the 1, 3 places. 1, 2, 3. So like here we go, 1, 2, 3. So it becomes 0.001. 0.6 minus 0.001 is 0.599. We want to convert this answer now back to our standard index form, so the decimal point's got to be here, 5.99. So we're moving right. Okay, so we decrease our exponent on the 10 by 1. So this was then 5.99 times 10 to the minus 1 in standard index form. The other method of adding and subtracting is to change the exponent using this law that we had previously, or this rule that we had previously. Change the lowest exponent in our calculation to the higher one, and then add or subtract. So if we've got 9 times 10 to the power 2 plus 7 times 10 to the power 3, this is the lower exponent. So increase this to 10 to the power 3. When we do that, we have to move the decimal point on our 9 to this make it 0.9. We have to move it left by one place. So 0.9 times 10 to the 3 plus 7 times 10 to the 3. Add these two numbers together. So 7 plus 0.9 is 7.9, and our powers of 10 remains as 10 to the power of 3. So 7.9 times 10 to the power of 3. Okay, let's use the same rule here that we used here. Okay, so this then becomes, we're going to use the lower exponent. So the lower exponent is minus 3. So remember, on our number scale we have minus 1, minus 2, minus 3. So minus 3 is lower than minus 1. So we're going to change this minus 3 into a minus 1. And when we do that, we have to change this 1 by moving the decimal point left 2 places. So we're going to move it here to make it 0.01. Now we can add the 6 to the 0.01. Or actually we're not, we're subtracting. So subtract 0.01 from 6, we get 5.99. And then our exponents on the 10 remain the same. So 5.99 times 10 to the minus 1. That's our standard index form. So the beauty about this method is that we don't have to convert back to standard index form. The answer is given in standard index form. Multiplying and dividing. This is easier than the addition, but nonetheless you have to remember what to do. So 2 times 10 to the power of 4 multiplied by 3 times 10 to the power of 3. Multiply the two numbers, so that's 2 times 3 is 6. Then when we multiply the exponents, we have to add these powers. So 4 plus 3 is 7. Okay? So remember our rules of indices. When we multiply, we add the powers. So this becomes 2 times 3 is 6. 10 to the power of 4 times 10 to the power of 3 becomes 10 to the power 7. Similarly, with dividing, when we're dividing powers or our indices, we subtract, so it'll be 3 minus 2. Okay, so 4 divided by 2 is 2, and then this 10 power of 3 divided by 10 power of 2, we subtract the 3, subtract the 2 from the 3. 3 minus 2 is 1, so it becomes 2 times 10 to the power 1. Okay, here I've given some examples. Work through them and see if you can do those. Here I've given a question in words, and we're using quite large numbers, so we use standard index form. Remember to convert this mass into grams, okay? And in this question, remember to convert this into meters. Okay, so that becomes 20 times 10 to the minus 6. 10 meters stays as 10, so that'll be 20. The volume will be 20 times 10 to the minus 6 multiplied by 10 multiplied by the width. Remember to convert this into meters. So centimeters is 10 to the minus 2, so millimeters would be 10 to the minus 3. Okay, and then remember, mass is density multiplied by volume.